Welcome to this lesson video. Today we'll be looking at sine law, or some of you say it's sine rule. Let us start. Sine law or sine rule is based on triangles. Now it doesn't matter whether it's a right angle triangle or it's an equilateral or it's a scalene or isosceles. As long as we have a triangle, we can apply the sine law. Now, before we look at the definition or the equation of sine law, we need to understand the angles and the sides. We all know that a triangle has 3 sides and 3 angles. Now, this is what is happening. The angle that you see here, we say this is angle A, or we can simply say it's angle A, as in like A. And then we also have this angle. This will say it's angle C, or we can simply say it's C. Then we also have this angle here, which is angle B, or we can simply say it's B. Now what you need to know is that the opposite side of each and every angle, we designate or label it with respect to the labeling of the angle. So let me just do this. This side, which is opposite to angle A, we will say it's side A. We use a lowercase a, and then for this one, it's angle. Let me use a color which is a bit visible. This will be C, and then this one will obviously be B. So in simple terms, this side we labeled it as side C, which is the lowercase of C, and then the opposite angle, it's angle C, which is this one. Same goes to A. This is angle A, and then this side it's angle A, and then this one will be, actually this side it's simply side A, and then this one it's side B. It's opposite to angle B. I hope you can see this. Now we can explain or write our sine rule. So sine rule, it says sine A. This A is an angle over A, which is the side, it's equals to sine B over B. It's also equals to sine C over C. So we actually have 3 equations. This might be the first equation. Remember, we cannot use an equation which has 3 equal sides. So it's either we use the first equation, or we use this one, or we can use this part which is equals to this part. It depends on the type of the question we are facing and the type of the question we are trying to solve. Before we can use the sine rule, let us quickly go through the derivative, the original equation, or actually where it was derived. Where does this equation come from? We need to know that. Some of the question might require you to actually derive the equation of sine rule. Now suppose we have this triangle which is ABC, and then we all know that this will be A, we have B, we have C, and then we construct a line from angle A to line BC, or we can say line A. And then we know that we are going to have a 90 degrees here, and then we simply label that this is F, it's line AF. And then from here we have 2 right angle triangles. This is the first one, which is A, B and F, and then we have the second one. I'm trying to separate the 2 triangles. Second one is this one, which is A FC. Now I'm going to start by focusing on triangle ABF. Now looking at triangle ABF, let us focus on angle B, this angle. We know that sine theta is equals to opposite over hypotenuse. In this case, we know that the longest side is BA or AB, and then the opposite side of angle B is AF. So we have sine B, it's equals to our opposite side, it's AF, actually this AF, let us simply designate, but then it's okay. We have AF, we have AF, we have AF divided by this side. We all agree that this side is side C. Then from there we make AF the subject of the formula. We know that we are going to cross multiply. We have AF, it's equals to C sine beta. Then for now, let us leave this equation the way it is. Let us go to the second triangle. We are looking at triangle ACF. And then in this case, you are looking at angle C. This is the opposite side, this is hypotenuse, and then this is the opposite side. So sine C, it's equals to the opposite side, it's AF divided by B. We agree that this side, it's B, this is our B. And then from here we make AF the subject of the formula. We are going to have B sine C, another equation. Since these two equations are equated, actually the subject of the formula is AF, we can simply equate the two equations. So let's say this is equation 1, this is equation 2, then it's equation 1, it's equals to equation 2, and then from there we have C sine, which is equals to B sine. And then from here, let us try to remove the coefficients on both sides. So we are going to divide by CB, both sides. Then we see that this will result into 1 multiplied by the remaining term. We have sine beta over B, it's equals to, same goes to this one, this will result into 1, and then we are left with sine, which is equals to C. Then this is our sine rule. And then to derive the sine A over A part is the same procedure, but then you are going to construct a line through here, and then you have two triangles, and then the procedure is the same. You simply derive this equation. We can also express it in this term, actually in this way. Instead of sine B, we can say B over sine, it's equals to C over sine. It's another equation, but we all know that the general equation we need to extend this to sine A over A. Now let us look at examples on how to apply this law. Our first example. Now before we can start by solving the unknowns, we need to label this. Now we can see that the opposite side is R, so this will be small r. Then the opposite side of this will be small t, and then we also have S. Now the question, we need to solve for the unknown sides and angles. So we need to solve for this angle. We also need to solve for this side and this one. Now we can see that when we look at angle R, we don't have the angle. We also don't have the opposite side. And then when we look at angle T, we have the angle, and then we don't have the opposite side. And then when we look at angle S, we have the angle, we also have the opposite side. So the first thing that we need to do, we can calculate the value of T using the angle and the side of S. So we have the angle S, we also have the side, and then we have the angle of the side which we are looking for, and then we can calculate the side. So in this case, we have sine. We need to express our equation in terms of the given diagram. So we have sine S over small s, it's equals to sine T over T. We have sine S, it's 40 degrees, over S, it's 30 meters, equals to sine T is 55 over the value of T, we are looking for it. Then from here we can cross multiply. We have 80 sine 55, it's equals to T sine 40. Then from here we can divide by sine 40 both sides. This will result into 1 multiplied by T. We have T, it's equals to 30 sine 55 divided by sine 40. And then the answer to this is 38.23 meters. This is our answer. Now going to our next unknown, we can see that we said T is equals to 38.23. So this side we have 38.23 meters. And then from here, how do we find the value of theta? Now what we need to know is that the sum of all interior angles of a triangle is equals to 180. So when we add angle T, R and S, the answer will be 180. So angle T plus angle S plus angle R is equals to 180. T is 55 degrees plus S is 40 degrees, and then plus theta is equals to 180. And then from here we have theta is equals to 180 minus 55 minus 40 degrees. Angle theta is equals to 85 degrees. No, it's actually 85 degrees. So we have 85 degrees here. Now we are left with angle R, which is opposite to 85. So it's our choice. It's either we can use S and angle S, R and R, or we can use T and R. Let us use T and R. So we have sine T over T, it's equals to sine R over R. And then sine angle is 55 over our T, we said it's 38 point, let me quickly check, 23 is equals to sine R, it's 85 over R. Then from here we cross multiply. we have 38.23 sine 85. It's equals to r sine 55. Then we divide both sides by 65, sine 65, sine 55 I mean. Sine 55. Then this will result into 1. Then we are left with r is equals to 38.23 sine 85 divided by sine 55. The answer is 46.49 meters. This is how we apply the sine law or sine rule. This is it for this lesson video. This is Bahula SJ. Thank you very much.